This presentation is brought to you by Arizona State University's Julianne Wrigley Global Institute of Sustainability for educational and non-commercial use only.
The question we start off with what should Phoenix do with basically 200,000 tons of organic waste? That's food and yard. So my name's Haley, this is Kimberly, and we were tasked to look at the creation of a circular economy, was specifically looking at organics. So we're tying off of Tomash and Patricia's project. So Kimberly's going to start off with what is a circular economy.
So we just wanted to give you guys a few definitions. So a circular economy is regenerative by design. So your biological materials going back to the earth in a closed loop, and your technical materials being recycled and reused and refurbished. And all of this is ideally done with renewable energy, so you have that closed loop system. A few other definitions that we're going to talk about. Feedstock is any raw material supplied to the machine or processing plant. Green organics are grass trimmings from trees and shrubs. And regionalization of feedstock, we're defining that as a regional system approach for businesses and technologies as part of a wide strategy.
So Phoenix, they have these diversion goals, 40% by 2020. So the first step is to look at what the waste is and so then you can work on how to divert it. So this is the waste characterization study that happened this past summer, single families, and you can see the majority of that, 40% of that is compostable, and then in general, more specifically, 29% is non-food waste. So that's what we're calling green organics for this study. So what are our options? What are we doing with this? We can waste to energy or waste to products. These are the techniques we looked into. So anaerobic digestion is basically waste to energy and waste to products. I'll talk about that in one moment. And then another option is incineration, which we do not recommend for many reasons. And then waste to products, mulch and compost, which Phoenix is already doing, which we looked into the economic benefits of that. So anaerobic digestion, what is it? So basically it's taking organic material and creating biogas and high quality compost. This is just an example about but this is just like the organic side of green organics. So a case study that I particularly am very fond of and I think is perfect for this area is Zero Waste Energy. They're a private company and partnered with the Monterey Region Waste District. So basically they built this facility, paid for the whole thing, and are running it and are taking the green organics from the Monterey Region Waste District. It's a 5,000 tons per year, that's TPY system, which basically is what I want Phoenix to start with. That kind of small scale, quote unquote small scale, tons per year is a lot, but with the 200,000 we have to start somewhere. And then so they create energy out of this through combined heat and power, but I recommend using the biogas to fuel your dump trucks. So basically they say about 1,000 tons per year creates or fuels a dump truck the whole year for an average route, which I think is really exciting. That's that circular economy right there that you're creating and you can see firsthand. So if Phoenix were to build their own with this company, Zero Waste Energy, it would cost about 3.1 in capital cost, which I think Dan just said it would be 20 million. So 3.1 compared to that is not much, but also that private-public partnership I think is important, so you can work with them and Zero Waste can actually build a facility for you. So what we recommend, I know Tomash was talking about regionalization versus consolidation. So we recommend regionalization of these 80 facilities. So that means basically standardizing the practices and messages throughout the state, and the valley. So basically, if someone lives in Mesa and works in Phoenix, they're not going to confuse out what can compost and what's happening to this waste. That's the regionalization we're talking about, not consolidation for anaerobic digestion. Because dry 80 is a non-continuous process,